Hello all, can you hear me or you are able to see my screen? I just have a quick confirmation so we can start in 2 minutes. I can see there are still couple of people joining, so maybe within a minute or two we can start. Just give me confirmation, guys, that you are able to hear and you are able to see my screen. Okay, just couple of more yes, guys, and then we can start them. Wow. Hope you guys enjoyed this session, right? Whatever we discussed. So before we start, let's have a quick recap that what all we learned. Okay, so we were able to see that what is the expected out of a data scientist, what is his role. Okay, so what all tasks he will be performing in day-to-day life, where will be his more engagement, right? So what all tasks he has to perform more and what all tasks will be the less kind of engagement, right? So we also able to see according to the job description and the kind of tasks which are performed by the data scientist, what is the different role which are played nowadays by the data scientist, by the machine learning engineer, by the data engineer or data analyst, right? So we started with somewhere with the approaches. What are the three major approaches? Then we went into different algorithm for these major approaches. Like we were able to see that majorly there will be three tasks which will be performed by the machine learning algorithm, which is regression, classification, and clustering. So we try to understand how the algorithms are working using the help of the graphics, and we also try to able to see what is clustering, how it is performed. We also able to see how the reinforcement learning is actually working. So we saw a complete roadmap that how to become a successful machine learning engineer or data scientist. And then we were able to see this diagram where we discussed a lot of things like what are the activities to perform, how the engagement will be, what is the major task that will be done, and how the things works. So the agenda will for the today will be like we will try to understand. Okay, enough of said, but what we do is we'll try to understand what is the entire life cycle of this machine learning process. That from data to model, right? Data to model until deployment, and how to once we build the model, how we can evaluate the model and what all the things which are going in between. So that's what we're trying to look at it. And then we'll try to touch upon few two use cases that I will make a code walkthrough today. And there is probably time permits. We'll start with the deep learning. That what is deep learning, why it is getting so much importance, what are the different popular frameworks which are available in the deep learning, right? And then how actually how the concept of deep learning came into picture. What is it that they are trying to achieve using the deep learning? What are the use cases? And obviously, we'll try to look upon what are the limitations, why most of the times machine learning algorithm fails, and what are the limitations with the deep learning. Clear, guys? I think you guys are clear with the agenda. Just ping me what our agenda is there. You guys are clear, so we can start with the process of the life cycle. That what is the life cycle and how it look like, and how data get converted into the model, and how model is ready. Okay, just couple of yes or no's, guys, and then we can start accordingly. We also able to see different terminology, and we also see what is the underfitting, overfitting, right? Let's start directly with the life cycle. Okay, when I talk about a life cycle, what is a life cycle? Life cycle means how the entire process of the machine learning algorithm works, like how we choose the data and then how it is implemented. Just to start with, I will give you a brief overview. Like what happens is first we try. There's a step-by-step process of the machine learning, how the prediction happens, right? So first, what we try to achieve is we try to take a data, then we try to prepare the data. We've seen that 60% of the time the data scientist will be spending his entire day or the span of his working hours, 60% of the time he will be doing a data cleansing. We also try to learn that why data cleansing is important, because if you want a robust prediction or you want a perfect accuracy or a robust model, so obviously we have to feed it the good data. And what are the issues with the data? We try to understand that what are the issues with the data, that how if data is incomplete, then obviously the prediction will not be accurate, or there will be underfitting or overfitting. The model will not perform consistently, or it may be possible that if you are feeding a raw data without looking at a certain condition, or required format, your model will not able to understand the pattern in the data, and it will fail accordingly. So that's why we are preparing the data. Then once we prepare the data, we should be aware that what is the use case that we are trying to solve over here. According to the use case, whether it is a regression task, whether it's a classification task, or whether I want to make a hybrid approach, that I will go for clustering first, and then I will try to apply the different algorithm of the regression or the classification. Accordingly, we can choose the model. Okay, once we choose the model, we try to train the data. Once we train the data, we also saw that what are the validation and testings and how are the methodologies working. We had a good discussion around yesterday that how we can perform a testing, at what stage we can do a testing, what could be a rigorous testing methodology. Once we do a testing, so maybe the model is ready and we try to make the prediction. Even before making the prediction, also we can do some hyperparameter tuning based on the validation data set, and then we can do a production test. And once we do a production test, after that, if you still feel that you're not satisfied with the performance of model, so you can go ahead for some automated performance hypertuning algorithms like grid search algorithm, or some other algorithm like cross validation algorithm, where we will be providing the set of range of the parameter information using which we will try to fine tune the parameters. Once we are satisfied with these parameters, then we will try to deploy this model to the different platforms, maybe a cloud platform, web-based platform, and then it will be available for the disposable. Okay, so that's how. So let's have a deeper look that how the things will start. The first thing will be inputting the data, right? First thing. So first thing, it will start here. So this is kind of table or data set which you will be having. Once you have a data set which is obviously pulled from the database, so what you will try to do is we'll try to see the different methods using which we'll do a cleansing or sanitization check. What do we mean by sanitization check? Let's say, so if I have a H column, then I need to check that whether this column has a complete information or not. But once I see that there is a completeness in the data, then we have to deep dive and take a look at the different columns and look at their data types. Let's say H column is a numerical column, then whatever values are present in the H column should have a numbers, right? So it should not contain the characters or letters. So that kind of check we can do. Once we do this kind of similar checks, then we can also look at the pattern of the data. We try to look at the different patterns, whether what is the highest value, what is the minimum value which is present in this column, right? So whether values are getting again duplicated, it may be possible that certain values are duplicated again and again. So that kind of observation we also try to do. So then once we do this kind of observation, or we may feel that we need to replace some of the data which is not showing the correct information. So maybe we do some technique using which we will try to manipulate the data. Let's say we trying to manipulate the certain odd data with the mean data of that column or median data, or we can see that if there are outliers present. Outliers means simply data which is far away from the highest and lowest range, right? So maybe a very different set of data which is giving altogether misleading information. So we'll try and check that whether this kind of data is present in bunch, or it is a very small amount of data which is making our outliers. So when we try to identify using different graphs and different technology, we try to remove unnecessary data so that there is no variation, much of variation in the data. So that once all these checks are done, so our data is ready. Okay. So this entire process has to be done pre-processing part. Then once our data is ready, then what we try to do is, let's like we saw yesterday, we try to split the data using the split methods, right? Leave one out, or say cross validation, or 10 trend test split. The different split algorithm or bootstrapping approaches are also available, using which we try to create the training data set, and we try to partition them. What we do is usually 70% of the data we'll try and partition it for the training purpose, and remaining we'll keep it for the test purpose. Because if I show all entire data set to my algorithm, it may be possibility that it try to remember everything, and on the basis of that, it will give me predictions, right? So what if a new data sets comes in which is never seen by my model, right? So how we are going to test the performance, if it is performing well or not? on the unseen data set. That's why we are having this strategy to split the data set. So we try to provide the maximum scenarios to our model using the train test split. And then once we do a split, then next stage comes in where we need to choose the learning algorithm depending on the business case we are trying to solve. So we have to choose whether I am going for regression, whether I am going for classification, or whether I will be doing some unsupervised learning like clustering. I have to cluster the entire data set into different regions. Maybe at that time it is possible that I can do the correct prediction accordingly. And before that, guys, it is very important. Once we do this data cleansing and everything, we obviously try to look at the relationship between the data. Like we will create a different visualization, maybe a bar plot, right? A pie chart, bar plot, or correlation plots, or density plots, or scatter plots, right? Or line plots, or maybe we create a box plot, right? Like this as a block plot, which gives me outliers if they are present. Okay. So this entire thing for 100% of the data set, and whatever values which may be lying outside this box plot limit may be the outliers. So I'm trying to visualize data first, then only I will try to fit an algorithm to it. That is the first thing. Okay. I hope you guys are able to follow this one. So where it starts, let's start again. The first data comes in from the database. Once the data comes in, we have to perform the sanitization check. What do you mean by sanitization check? Maybe data cleansing, data cleansing, checking the duplicates value, checking missing value, checking NA values, right? Checking NA values. If there is any outlier present, and are there any redundant features? Everything we'll try to find out. We try to find out whether there is a relationship between the columns. If all the columns are necessary, let's say I have thousands of columns, whether I need all those 1,000 columns or not. And I using the graphs, we try to visualize the different graphs and different relationship among the data set, right? So once we visualize the data set, once we see, then that is especially called as, guys, feature engineering. Okay, it's a separate topic where we say that it is a feature engineering. Once we clean the data, we need to select the feature which will be responsible to perform the predictions. So that is called as features. What is feature? Is nothing but saying the columns, the column using which we're trying to predict this. Let's say in this case, we are taking a business case of, say, customers' bank data. Okay, because this is a bank data and this is the data of the customers. So the customers are giving their different data set, and what we are trying to do here is whether we are trying to predict whether this loan application will get approved or not. So this is a binary classification problem, right? So this kind of age, customer score, right? Gender, his credit score, or some other related information. What is his monthly income? Has he defaulted previously or not? There will be a lot of columns which will be available. So we'll try to perform all the data cleansing tasks, whether we'll check whether relevant data types are available within particular columns or not. And then we'll try to understand what is, once we do, we are ready with the data. So the main feature selection technique will come into picture, right? Feature selection means what? If I have 100 columns, let's say, so out of that 100, whether I'm going to choose all 100 columns in order to do prediction, or do I need to look at the data and try to understand whether can we reduce this 100 data set in somewhere around to 50 or 60? Now, I'm not saying exactly to 50, 60, but try to possibly cut down the entire data set without losing the significant information in the data. We'll say, what do you mean by significant information? Let's say for that purpose, the feature selection and the visualization techniques will come into picture, right? So if I can say, let's take an example of age, and let's take an example of, let's say, income, right? So if I see that within these two variables, there is a strong correlationship. Okay, there is a strong correlationship, let's say around 90%. 90% correlationship lies between these two columns. Okay, between these two columns. So maybe it is possible that I don't need both the columns at a time. So I can drop one of the column and I can choose only age instead of the income. So I'm just taking a pseudo example, guys. I'm just taking an example, but you don't quote me that without income, how you can predict whether your loan application will get approved or not. I'm just taking an example, right? So maybe we'll try to understand what is the relationship between the credit score and the income, or age and the gender. And depending on that, we try to see if there is any correlationship exist or not. If there is a correlationship exist, maybe I can see that I don't need to take all these columns into consideration, that all these features into consideration when I'm trying to build my model, right? So maybe I can choose few of them, and then that's enough for me to build my model. So that's how we'll do a feature engineering. Okay, so for that purpose, we'll try to have a look and try to have a different visualization along with the target column. This is the target because we need to decide whether loan will get approved or not. First, we'll try to look at the relationship between the target column and the feature column individually one by one. Let's say loan with the credit score, loan with the gender, loan with the income, loan column with the age. And similarly, when we are doing this, we'll also try to look a relationship between the feature itself, like age and income, income and gender, right? Gender and score, or score and age accordingly, or gender and age, income and age. Accordingly, all the possibility permutation combination we'll try to look into, take into consideration, and then we'll decide what are the final things which will go into the machine learning, right, model. So that's how we'll do. Once we select the features, then we'll do splitting actually. Okay. So I do splitting of the entire data set into 70-30%. This I will keep for testing purpose. I will not show it to my model, and this I will dispose. When I dispose, and the like kind of problem you are trying to solve, just can you guys guess that what kind of problem you are trying to solve here? Whether it is a regression problem, okay, whether it is a regression problem, whether it is a classification problem. Okay, we are trying to find the class, right? Whether it is classification or whether trying to find out the different group of customers, like clustering. So option 1, 2, 3, guys, just ping me like what you think, that what kind of problem we are trying to solve here. So I on the basis of that, okay, we can consider that what kind of algorithm we are going to choose here. So yes, yes, it is correct, sir. That classification problem we are trying to solve. Maybe a few couple of more people who can even guess that what kind of problem it is, whether it is a classification, whether it is a regression or clustering. So are you guys agreed to this, that it is a classification problem or not? So a couple of more responses, guys, so we can understand that we are able to follow along with whatever we are trying to achieve here. A couple of more responses, guys, come on and come up with your suggestion that whether it is a classification problem or whether it's a regression problem. And if it's a classification problem, so you agreeing to the task that we need to perform the classification on this basis, so we can achieve whatever we are trying to do. Come on, guys. Few more votes, and then we can go ahead then. So it may be a confirmation that you guys are trying to follow what we are trying to achieve here. Yeah, classification. Few more, guys. Few more votes, and we can go then. Couple of more. So you are agreeing that it is a classification problem, right? So we can say that it is a classification problem because what we're trying to achieve here is we are not trying to predict any number, or we are not trying to. So it's Shanmukh Priya is saying it is a regression. Okay, guys. So I think we should take a couple of more votes. So what could be the situation or business case we are trying to solve? Whether it is a classification, so we can get a majority of votes, and I can clear you that why it is a regression, or why it is a classification problem, or why it is a clustering problem. Maybe I can get understanding or get a feeling from you guys that whether you are able to follow or not. So guys, come up with the opinions that whether you agree to whether this is a classification, or you can agree to class regression business case, or whether it is entirely different, it is a clustering algorithm where we need to choose in order to solve the situation. You guys are clear that what business case we are trying to solve? Depending on the customer data provided, we are trying to solve whether this customer will get approval on for the loan or not. Okay, so that's the business case we are trying to solve, and accordingly we have to come up with the algorithm, that what kind of algorithm I need to implement. In order to implement the algorithm, I need to understand that whether what kind of task we are trying to perform over here. Rita is saying classification. Yes, guys. What else? Anyone differ? Anyone trying to differ with this opinion, whether it is a classification or regression, or anyone having any other suggestion? What kind of problem we are trying to solve, or any other approach is available as per your knowledge, whatever we have seen till now? What do you guys think? Just, just quickly, guys. Just give a reply so we can go ahead, and then we can try to solve this use case. Okay. Couple of more guys, couple of more responses, then we can try to understand what we are trying to achieve. Come on, guys, there are 560 participants. At least some of us can even drop me, right? Ping me, right? Quickly. So whether you guys agree to this is the regression or classification or something else entirely. I think we will go with the majority. That majority of us are saying it's a classification problem. I will tell you why it is a classification problem. Okay. So correct, it is a classification problem because if it is a regression problem, what we do is we try to predict the number. We try to predict any continuous number, right? 1, 2, 3, 4, 5, or maybe range 10,000, 1K or something like that. But what we are doing here is we are just trying to predict a binary category, right? Yes or no, right? Yes. What we're doing is whether you are getting yes or no, whether there will be approval for the loan or no. So it is what we're doing is we're trying to classify the data into two categories, binary category. That's how, guys. That's why it is a classification problem. It's a binary category classification. So whatever algorithm I need to choose, I will obviously yes binary classification and theta, correct. So whatever algorithm I have to choose a classification algorithm. So what are the classification algorithm available? Decision tree, K nearest neighbor. I can use a logistic regression because logistic regression can also be used for the classification, and linear regression is normal linear regression used for the regression. Okay, even though the logistic regression has the term regression, but it is used for the classification purpose as well. Okay, so accordingly, what I will do is whether I will try and implement one single algorithm or whether I am going to apply multiple algorithms. It's again a choice. Yes. What we can do is we try and first what we'll do is if I am clear that what kind of algorithm now I'm going to choose. Okay, I understood that this is a binary classification problem and I had to choose between the algorithm. So usually traditionally what we do is we don't go with a single algorithm. What we can do is we try and start with one algorithm, let's say SVM, support vector machine. I will try and take this algorithm and try to fit in this algorithm first, and I will do some hyperparameter tuning, let's say, and I will try to see a accuracy score for one algorithm, and I will see whether I am satisfied what is the score coming. I will not stop over here, guys. Okay, I will not stop here. No. He's saying that regression has occurred in the oral situation, right? No. Regression is not occurring. Say, let's put it in simple terms, right? So, like I told you, regression we're trying to predict any number. Are we predicting any number over here? That what will be the number? Let's say, are we predicting that what will be the temperature today? Are we predicting any sales today? Or are we going to predict that what kind? Is there any BMI or not? Now, what is my BMI based on my height and weight? Or are we going to predict what is the height? Or are we going to predict what is my age? Right? Age is a numerical variable, right? So are we predicting income based on the data? No, right? All these numerical variables we are not trying to predict. What we're trying to do is I already have a labels whether I'm going to approve this loan or not. Yes or no. That's what I'm doing. That means I'm trying to bifurcate in these categories. But categories, whichever I am having available with me is only two, right? So that's why it's a binary classification. If it is more than 2 or 3, then it will be a multi-class, right? So that's how simple understanding, guys. And clustering, you already know that I'm trying to break the entire data into the different chunks. So that's how the clustering will work. So that's why I hope yes, I got the response that you were able to understand why it is called as a binary classification, right? So we what we saw is once we are aware that it's a binary classification according to the available classification algorithm, we'll try to choose the algorithm. So what we saw is, can we take only one algorithm is enough? Taking one algorithm and prediction, going for the prediction, or can we take a multiple algorithm? That was the question we were trying to discuss. Should I go with single one or should I go with the multiple algorithm? So how the technique works over here is, first what I do is I try and take one algorithm. Let's say I took SVM. I will try to train the data, right? I will try to train it. I will try to look at certain parameters, maybe, or at the time before even before the training also I can do hyperparameter tuning, or after the prediction also I can do a hyperparameter tuning, and again I have to go for the retraining. Okay, that is also possible. So it's again depends, like, but usually what we'll do is we take one algorithm SVM. We try to take one algorithm first instance SVM. We try to train it without doing any hyperparameter tuning, and we try to validate that model. So what is the accuracy it's giving? Let's say it's giving me 92% of accuracy. Okay. So I will not stop over here. Why to stop? Because I know there are certain other algorithms which are available site. So it may be possible that according to different situations, right? Some other algorithm may perform very well, okay, with the data. So I don't know yet. So what I can do is I can do an experimentation. I will go with SVM. I will train the data and I will look at the accuracy. What in second step, what I will do, I will go with a linear logistic regression, right? Logistic regression I can take second algorithm. I can take go for the training and I can check the score. Let's say logistic regression gave me this time 93%. Okay. And third stage, what I will do, I will go for even other algorithm. So what we'll do is we'll try to take 4-5 algorithms. We try to check the accuracy, and let's say K9 give me accuracy of 95%. Okay. So accordingly, I will try 4-5 algorithms all together, and I will see how they are performing and what kind of accuracy these guys are giving, right? So once I see what is the accuracy, and along with, I have to also consider the business criteria. Sometimes there is a business criteria that where accuracy has the highest importance. Like we saw the case of the classification where I need to classify looking at the X-ray image. I need to classify whether this person is having cancer or not, right? This person is having cancer or no cancer. At that time, accuracy is it's the utmost important. So I will not look for the scalability. Scalability, what? How fast my model is able to give me a response. That is the speed. Okay, speed of the algorithm. So I will maybe at times, or speed of the algorithm, or you can say what kind of resources my algorithm is using. Because whenever you're trying to train your model, obviously you require RAM. Okay, you require RAM in order to perform a computation. Also, you will require a cloud space, right? Or maybe in GBs, let's say 120 GB, 30 GB, 40 GB. You will also require a processor, highest processor. And the processor will not be one processor. Maybe you require a multiple processors according to the speed you are trying to achieve, right? So all this configuration is available in the cloud. So you have to also look, because all this configuration will not be free, guys. Okay. So there will be charge for everything, right? You have to measure the cost for everything. So according to the business situation, according to the decision, what is available and how fast we are trying to predict and what is the case, whether there is accuracy is important or whether speed is important, I can make a trade-off between speed and accuracy. Okay, sometimes it is a situation there where business case is not critical. So I can go for the mix. I can say I need a moderate speed, but accuracy I'm okay if I'm getting a moderate accuracy around, like say 95%. Okay. Even though my model is not giving 99% of accuracy, I am good with the accuracy of 95%. 95% is okay for me, but it should also give me a speed. Within fraction of second, it should be able to give me the prediction. So at that time, I am going to take a mix of it, and then I'm going to decide, okay. So whatever situation is there, accordingly, I can go for the algorithms or multiple algorithms. And once it is done, so we can use the validation data. We saw the accuracy and then trained model, right? We got a trained model. Once we got a trained model, right? So we have still, guys, we are still working with 70% of the data, right? So yesterday, I think a couple of us had a question that at what stage and at how many stages we can do a testing and validation, right? So we saw here that at the time of the training only, once we train the model with the 70% of the data only, out of that 70% of the data only, we are trying to check the accuracy, right? We choose different algorithms. We saw a different algorithm, which algorithms we can use according to speed and accuracy. We took a combination of it, and then on the basis of that, we try to find out the validation. Okay. Once we are satisfied with it, then model will be trained. We can declare, okay, model is ready for the prediction. Then we can come to this 30% of the data. Okay. We can come to this 30% of data. Then out of this 30% of data, which is not seen, unseen data, right? Which is not seen by my machine learning algorithm, because the algorithm was till now was only working with the 70% of the entire data set. And this is completely new data set. Now this is the triggers test which will perform, because model is trained, model is ready. So we'll try to dispose this 30% of the data with the model, and then we'll see how it is predicting. Okay. And for prediction, we'll try to check different metrics which are available. If it's a classification, we'll go for accuracy, or what is the precision, what is recall. There are different metrics which are available. On the basis of this metrics, or you can say metrics like precision, right? Metrics like recall. Okay. Sorry about handwriting, guys. Or how can I can directly write text. Okay. So you can say recall. Recall is there. Precision is there. Okay. And we can also check F1 score. Okay. These are the some popular measure along with this, and this is called somewhere true negativity, specificity. This is nothing but this is the same terms which are coined for this recall, precision, F1 score, right? And we can also check if whenever you are using multiple models, right? Whenever you are doing multiple models, then at that time you need to check AUC score. AUC score. Because you need to understand out of these multiple models, which one is better. So AUC score will give you a better idea about which model is performing better along with the accuracy, right? So these are certain measure for the classification algorithm. And obviously for regression, we will go for the R square. R square is nothing but, guys, R square is a measure of how much variation my algorithm is able to predict. Because what we're trying to do is, right, in regression, we're trying to make a best fit line on the data, right? If this is my data, so I'm trying to make a best fit line, and I'm trying to reduce the gap between actual point and this prediction point, right? This error I'm trying to reduce. So I'm trying to explain this variance, right? So that is my regression. That's why there is a R score, mean squared error, okay, and root mean squared error. These are the concepts. What is error, guys? Error is nothing but difference between predicted and actual, right? Difference between, let's say, difference between predicted. If my y hat is predicted, and I'm trying to take a difference between actual, right? Let's say y hat and y bar. Because all these are numericals, I can directly take the subtraction. Let's say predicted value is 100, wherein actual value is 90. So I got a difference of 10, right? So maybe my model is performing with only 90% accuracy, not 100%. So again, this kind of measures are called as mean squared error, R square, root mean square error. And there is also one more measure is there, which is called as adjusted R square. Okay? Adjust R square. When we use adjusted R square is when we are having the multiple columns, right? Let's say more than 50, 60 columns. Maybe it is possible that we also saw that what is the biasness in the model. Maybe because of the magnitude of the columns. Let's say in this case, if I look at the number, the prediction, the scores, credit scores are between a range of 1 to 10, right? The income is like between lakhs, and age is between 42. So what I can understand is sometimes if I'm not if I'm not treating my features very well, so maybe 5 lakh number or this income number 5 lakh, right? So if there is any small change, okay, any small changes in these numbers, any small changes this column will affect this loan prediction very heavily. Okay, heavily. So small change in one column is creating a very high change in the loan. So that is called as biasness. So what we can say that my model is biased towards certain feature or certain column. So that is called as biasness. So we have to also, that's why we spoke about the regularization techniques. So we have to also take the regularization techniques, and in order to avoid these things, the inflation which is created by the biasness, we also have a measure which is called as adjuster R square. Okay. Once we are satisfied all these things, then maybe we can think about the deployment or final model, which will be available for the disposal of the user. Okay. That's how the things will work. We also, guys, I forgot to tell you that between when we're doing the feature engineering, when we're taking the data and trying to select this data, okay, at that time when we are doing the visualization also, at that time there is certain techniques, okay, just like the PCA and LDA. These are the techniques which will help us to reduce the dimension, guys. Okay, these are the dimension reduction techniques. These techniques are called as dimensionality reduction techniques. So what do you mean by dimension reduction? Means if I have 100 columns, let's say, out of that we saw that how much columns are making sense. So maybe can we reduce these columns to 50 or 60 or somewhere close. So that process of reducing the columns from 100 to less and without losing the information can be done using this algorithm. PCA, principal component analysis, and LDA. Okay, these are the algorithms which are available. Using these algorithms, we can also do a dimensionality reduction. Okay, so that means we are trying to reduce the number of columns without losing the information, but still my model will be able to accurately say what will be the prediction whether my loan application will get approved, yes or no. Okay, guys. So that's how it will work. So we'll try to look at the real use case. Before we try to look at the real use case, which is implemented, Amar, can you just launch a poll? Okay, just Amar will launch poll, guys, and at least just give a opinion that whether you are able to understand the life cycle in better way. It is clear that how the right from the inception, that where we're taking the data till the model evaluation, it is okay. So if I get a more yes or no, accordingly we can proceed, guys. So let's see how many yes we get and how many yes we are getting. So we can make sure that you guys are following it correctly. So guys are through with the concept that how machine learning algorithm will work, right from data to model and then performance. Okay, guys. On guys, we have like more than 600 people here. So at least I expected everyone to at least join in this poll and give your option. So it will be a kind of confirmation of feedback for me so that I am able to explain the concept and you guys are good to go. But because once you guys are aware that how the process is working, then only code walkthrough will make sense, guys. Okay. Real-time use case, like how real-time implementation of the algorithm is done and what are the different stages, like we spoke about the visualization, we spoke about the data cleaning technique. All that code I will make a walkthrough within a couple of minutes. So only 200 people have responded till now. So be active, guys. Try to participate. So it will give us a good feeling that you guys are ready for the next level. Okay. So once you understand this thing, then only we will be able to move ahead then quickly. Come on, guys. Just take 1 minute or 2 minutes. Okay. And within 2 minutes, I will wait for 2 minutes, guys. You guys to respond. So I hope that everyone will respond to this poll. And then on the basis of this poll, I will be able to make a draw a conclusion. Okay. So we can go ahead then. Just for a couple of minutes and then we can start then. Just quickly, I'm giving you guys 2 minutes. And within 2 minutes, just try to respond it. All right, guys. So last 1 minute, so we can start. Whosoever not done a poll, please go ahead and do a voting, guys. Do voting. I can see only 300 people still now. Just last 1 minute, guys, and we can start now. Code walkthrough. Come on, guys. At least try and participate. Nothing wrong in it, right? It will give us a feeling that you guys are very, very well aware of what is the process and how it is working. Come on, guys, fast. Vote it out. Nothing wrong in voting, right? Okay, all right. So I can see at least 300 people are saying yes. Okay. So I assume that everything is clear, guys. So you are very well aware that what are the major tasks we're trying to perform. We saw real use case like if I am providing customer information based on his age, his income, his gender, his credit score. So whether my machine will be able to correctly predict whether the application will be approved or not, loan application, right? So we saw different stages where we perform the different stages where we perform the different feature engineering, where we try to saw how to choose the algorithm and all, right? All right, guys. So let the poll continue, but we'll move ahead without wasting time. So what we can do is right now, we try, at first, before even we try and understand, let's take example, simple example, graphical example, that how the things are performed, right? So let's take example, very popular example, that how the spam and non-spam email classification works in the model, right? So whenever we had having a number of emails which are coming into the mailbox, right? So again, guys, just quickly tell me whether again email classification, whether it is a spam or not, right? It says classification model, right? So anyone having doubt, right, whether it is not a classification regression problem, or everyone agrees to this, right? So because if I'm trying to find whether my email is a spam email or normal email, obviously I am going for a classification model here. But are you guys able to, or you can say you guys are able to agree with it that it is a classification problem, or you guys are having any other opinion? That no, this hypothesis is wrong. This is the reason. And please tell me also reason, guys, why you think this is not a classification problem. Then quickly, guys, within 1 minute, because without using the time, we can make a code walkthrough, because very beautiful use case we'll see here in the healthcare application. We're able to decide on the basis of the data that how machine learning can view us, right? So whosoever guys disagrees to it, maybe give me a reason, but why you want to disagree, or maybe you have a different approach to solve this problem. Okay. If I don't see any different approach, then we can go ahead, right? So yeah, everyone is saying that it's a classification problem. I assume that you guys don't have any other opinion, so it's a classification problem. So what happens is, let's say we can solve this problem two ways. Okay, one way is I look at the subject line. Okay, if I subject line, and I will train my model according to the subject line. So if my subject line is a if particular words are available in my subject line, maybe I will classify it as an spam or no spam. Or what I can do is, if I want a more accuracy, I can go and check the entire email. I try to summarize. Again, it will become an NLP problem, that's natural language understanding, because I have to look at the words, I have to understand the words, give a weightage to the words, what are positive words, what are negative words, right? Maybe what I can do is, I try to read whatever words are present, whatever things are written in the email. I'll try to pick up the words and I will make a table out of this word. I'll just give you a brief overview, guys, how NLP things will work, right? So let's say there is an email which I have received, and out of that, I will try to find out that what are the unique words. So let's say in the mail, we saw that thank you, yes, or some other words. Let's say goodbye, thank you, and then say yesterday, meetings. Okay, this kind of words, meeting, cancelled, or something like that. I saw that there are words, different words, right? Different what we saw in the mail. I gave entire mailbox, whatever email is there, whatever emails are written. I took entire sentences of a paragraph and gave it to the machine learning algorithm. What machine learning algorithm will do? is out of this entire line, we try to bifurcate them into the words, right? Different words. Word one, word two. Let's say, let's say I receive an email at, okay, Vikas, hi, thank you very much for your response, but today's session has been cancelled. Okay. So once I see today's session has been cancelled, so what will be the unique words? Hi, Vikas, thanks for response, right? Session cancelled, right? This session cancelled today, right? Your response. This kind of unique words will be there, right? Out of the entire sentence, what I will do, I will try to find out the unique words and I will try to look at the frequency of these words. So how frequently these words are occurring. This, let's say this word response occurred 3 times. Thank you occurred 2 times. Meeting cancelled occurred 1 time. Let's say, thanks for your response. See you, or some other words like, and try to understand what is the frequency of these words. Let's say this word appeared 5 times. And according to the frequency, whatever word appeared in this email, right? Whatever words are appeared, I am going to assign the weights next. I'm going to assign the weights. Higher the word count, higher the weights. Let's say I am assigning this word which is appeared 5 times, maybe a higher weight, let's say 0.8. This weight, okay, 0.8, right? 0.8. This word appeared only once, so maybe I can give 0.1. And this weight, thank you, appeared only 2, maybe less weight than less, 0.3, 0.2. And for the response, maybe it is appeared 3 times, I will give a different weight, let's say 0.4. Okay, so let's use different color. You guys are able to understand how the things are working. Sorry for the bad diagram, guys, but we're just trying to understand quickly that how jobs could be. Okay, guys, we are talking about Kavita. Yes, we are talking about only one email at a time because we are not taking simultaneously all the email at a time. We just taking example that we have received the emails. Okay, out of that one email I have taken right now for first iteration, and out of this email, okay, let's try it correctly again. Better way. This is the table which I have created. It is called as word to vector, guys. Okay, just for your understanding, I'm telling you, you want to be going to word to vector. So what I'm going to do is, out of the entire sentences which are written like this in the email, I'm trying to bifurcate the entire phrases into the words. And whatever words appear, let's say W appeared, words, let's say I appeared, response appeared, meeting cancelled appeared, thanks appeared, right? E. And I'm going to count simply the count. Okay. First will be count how many times this appeared? 5 times. This appeared 4 times. This appeared 3 times. This appeared only 1 time. Let's take a simple example, right? Now we will not go into detail because it's again an NLP problem. We will try to touch it again at some later point of time when we are using it. It's an NLP problem. So we are taking just simple example how email classification can be done using the machine learning algorithm. We took one email. We try to look into the details, what is written in the email. So there will be obviously the paragraphs of the email. Once we see any paragraph, we'll try to break it into the sentences. Once we break the paragraph into sentences, we will further go ahead and break into the words. Okay, that's how it will go on. First paragraph, then sentence, then word. And we'll take one word and try to create a matrix out of this word. And we'll try to count the frequency, okay? With what frequency this word is appearing. Once I know the highest frequency word will get the weightage accordingly. So if it is highest frequency, I will give a weightage, right? Let's say 0.8. For this, I will give a lesser weight 0.6. This one will have even lesser 0.4. And this one will have a even lesser 0.2. So I will try to make weights, and then I will try to multiply these weights by using this frequency, and then there will be a final number coming up. I'm not taking exact guys numbers. Let's say I'm taking just pseudo example. This weight, this final score, okay, we'll call it as a score. This is the final score which we are going to consider once we apply the once we multiply the frequency with the weightages, and then we are getting score. This is 10. Okay, this is let's say 8. Just example, no correct example I'm taking, just for the simplicity I'm taking this example. It got 6 and it got a 5. So what I can do is I can understand. Now I come up with the score. What is the score? What is the weightage? And then what will be the final score according to the weightage and all. And out of that weightage, I will see that this word has got the highest weightage, right? This word has got highest weightage. After that, this word is got highest weightage. Let's say this word was response and this was the meeting. Let's say meeting and response. On the basis of this meeting and response, I can understand, okay, what is the importance there, whether there is a positive emotion out of it, or whether there is a negative emotion, right? Or whether it is important or not important, any kind of criteria. So here the criteria is spam or no spam. Okay, no spam or spam or no spam, right? Spam or no spam. So according to the weightage of the word, or whatever the weightages are there, accordingly model will try to understand, okay, what is going on, what is the importance here, and we try to take bifurcate them whether into positive or negative category. In this case, there will be certain words which will be assigned to spam. There will be certain words which will be assigned to non-spam. On the basis of the frequency, where my machine will be able to bifurcate whether these words belong to spam or no spam. And then on the basis of that, I will classify this email, whether it is a spam email or no spam email. And then that's how the bifurcation is doing this. Okay, clear how the NLP program will work. This is a simple example because whatever example we saw is we took the data, right? The different table data, and we try to dispose it and we try to make a classification. What if I'm not getting the structured data? This was structured data, right? So I was getting unstructured data, text data. This was the text data, right? This is the text data which we are getting, and how that text data will be consumed by the machine learning algorithm. That's what simply a very quick brief overview we try to solve. So you guys are very thoroughly aware that how the things are working. If it is a use case of the numbers structured data, okay. Next is the structured data like this, where we are trying to look at the customer data pertaining to the bank, and then we're trying to decide whether a loan application will be approved or not approved. This is called a structured data. We'll try to look into more, try to understand what is structure, what is not structure. But just for the basic understanding, if I getting any table in sort of a particular requirement or a particular way of the data, then it is called as a structured data for that purpose. And if I'm getting any text, right, like this, of free form of data which is not structured, right, because nothing is structured. As and when you wish, you can write the paragraphs and sentences, right? There is no rule as such. Maybe there were corporate etiquettes when we write the email, but there is no as such hardcore rules. You can write whatever you wish, right? Let's take example, right? So at that time, how the email classification will be done on the basis of spam and not spam, we have seen on the basis of the unstructured data, right? Once we know that how structured and unstructured data works, that's how it will get into the machine learning, and that's how machine learning will be able to understand. Okay. Now, I hope I made you guys very clear that how the entire process is working, and looking at the one real-time example also. So we'll try to look at the real use case where we'll try to find out. What we'll do is we'll try to find out looking at the patient's data. We'll do it's a patient's data will be for the different data which is collected for the patient for the purpose of detecting whether this person has any sleep disorder or not. Okay, so let me quickly share the code in the yes. Okay. The problem we are trying to predict over here is what we are going to do is I have collected the data for my patients. Okay. Now, I will not go directly into the data, what is the data, but I'm trying to tell you the use case. That nowadays sleep disorder has become very popular or very prominent disease among the people. Okay, because of the stress level, because of the lifestyle, right? Because of the food habits and all. So we have a different disorders which are coming into the picture. So this is very beautiful example, guys, in the healthcare where we're trying to solve healthcare industry. So this is a particular use case which has been solved using the machine learning. It is a very popular use case that we are trying to predict whether basis of the data which is collected from the patient, so whether this patient having a sleep disorder or not. Okay, this is a simple use case, and in this case, what we're trying to do is we're trying to make a classification problem, because I will tell you as and when we go ahead with the categories and all. So there will be majorly three categories. Okay. So three categories we trying to find out whether this person has a disorder. If this person has a disorder, yes, or whether this person is not having any disorder, no disorder, or third category, whether this person is having a apnea. Apnea is somewhere between disorder and no disorder. Apnea means, let's say you took the entire night a very good sleep, still you feeling tired, right? Even after sleeping 8 to 10 hours, you feel sleepy, or maybe you were snoring, or you are making very bad voice when you are sleeping, or sometimes your breaths were, whatever breath you are taking was stopping in between. Okay, so breath was not continuous. Whatever breath you are taking was disturbed, right? That means you did not have a very sound sleep in the night. So this kind of categories, three categories, we'll try to solve using the patient's data. Okay, clear, guys? Just ping me that what problem you are trying to solve. If your guys are clear with the use case, then we can go ahead and try to understand what is data available. Then how can you import this data? How we can do a visualization and then build a model and then look at the accuracy. That's what we'll try to do. We're trying to predict sleep disorder. Just quickly ping me, guys, that you are able to understand the use case. Okay, and this is a real-time use case, guys. This is nothing of fancy data or hypothetical data. This is a real-time use case which has been solved using the machine learning algorithm. Because in the healthcare industry nowadays, mostly people are trying to analyze different data. Okay, and with the help of the machine learning, how quickly we can go. Because let's say if I have an application, why this kind of applications are created? Because I don't even in further if it further what could be the use case is that whenever you are going towards the doctor or something like that, you have to take appointment. You have to make sure that doctor is available. Also, you have to make sure that you are adjusting time in your daily routine, right? You have to take a separate hour. You have to visit the doctor, and okay, and on the basis of that visit, you have to pay the charges to the doctor, right? And accordingly, once you pay the charges, everything goes on. Then you have to manually go, and then you have to perform certain checks with the doctor, right? Maybe doctor will say, okay, now you have done a check. Now you again come back. I will try to analyze your data. Then we'll try to find out we'll try to analyze your data. Okay, we'll try to looking at your symptoms and everything. We'll try to see, and then next time when you comes in, maybe you start your medication. Okay, this is a long process now. You have to visit doctor. You have to take appointment. You have to make all the necessary things, and then in the end, we have to understand that whether I am having certain disease or not, right? Once you make all the tests and certain diseases available or not, then maybe doctor will start telling you that, okay, you can start taking this medicine, or you can start taking this kind of actions. Let's say if your health side is sedentary, you're not doing any workout or exercise, then maybe he will tell you that, okay, go for this exercise, go for the yoga, take this kind of food and everything, and take also this vitamin B, C, D. Nothing, he will try to fool you around, right? This is the simple thing they are doing nowadays. Okay, doctors are in vogue, and I'm not trying to blame, guys. Doctors are there because we have seen the COVID situation where doctors were in the front line, where they were able to help. Because there are certain also people where people are getting fooled because they are charged very heavily for the consultation by the people, right? So how everyday life can be impacted, that rather than doing all these hectic things, what I can do is I simply create a data of my patient, or I have an application. Okay, simply nowadays everyone is using a smartphone, mobile apps. I take a mobile app application, and whether in mobile app application I can feed my data, right? Whether or you no need to your feed your data. Everyone having smartwatch, right? Everyone is having smartwatch nowadays. So this smartwatch, what will do? It will take out the data from you. That what was the duration of hours where you were, what was the duration of hours where you were able to sleep, sound sleep. Okay, what was the duration of the sleep in that duration? What was the heart rate, right? Let's make it better. I'm trying to write it somewhere. Okay. So this is your smartwatch, right? You are wearing all the time, where you sleeping also. Out of this smartwatch, you can generate different data set, right? Smartwatch will tell you whether your life is sedentary or not, whether you are doing exercise or not. If you are doing further exercise, what kind of extent of exercise? Let's say in the terms of the steps, how many steps you are taking, right, every day? Let's say 10,000 steps on just example, right? Okay, and also sleep. What was the duration of the sleep? Also, for how many duration, whether it was a sound sleep or not, right? This kind of data is already generated using your smartwatch, right? Using your smartwatch, this data is generated again. This heart rate, okay, what was your heart rate? Also, looking at the different lifestyle, we can also say what could be your stress level. Okay, I can estimate your stress level. So different kind of data set, or you can say also oxygen level. Nowadays, oxygen meter is also inbuilt in the smartwatches, right? So different data is created using the smartwatch only. You don't have to feed anything. So once you connect your smartwatch, okay, your application, healthcare application, right? Smart healthcare application, let's say Healthify Me or something like that. Okay, healthcare application. This healthcare application, every day it in the background you are sending data. This application is available within your mobile phone only, right? So I have a data. So what I can do is I can run a machine learning algorithm model in this data, which is pre-built again in this application. And on basis of that, I can directly give you result, right? Whether you are having a sleep disorder or no, okay? Or whether you are sleep not having, you are, or whether you are in between disorder or not having a disorder, there is in between, like whether you are approaching towards the disorder or not, in between stage, right? So this could be three categories. So imagine guys, entire thing, like right from the data collection to analyzing the data and symptoms and looking, even after once you are diagnosed with the data, even that can suggest you the medications. Okay, based on these symptoms, you can suggest you the medication, that you can include this healthy food. You can suggest also that you start exercising. This is your target for daily steps. Okay, once you take these many steps, your target is complete, and you should eat this kind of vitamins and all, or some other medication, guys. Correct? So entire life cycle, because you guys just wearing a smartwatch, you are creating a generator. It's a beautiful example, guys. See, without knowingly or unknowingly, you are creating a lot of data, and that data is even captured by this application. In the background, is using machine learning algorithm, and it trying to analyze or give you according to your symptom. And even after you predict your stage or symptom, whether you are having this particular symptom or not. On the basis of that, it's giving you medication base. And all these things that comes at a very less cost, affordable cost, right? Very affordable cost. So you are saving your hours, you are saving your the hectic. Let's say you are saving all the time you have to take out to visit the doctor, make the different tests or something like that, or you have to take pass all the, let's say, traffic. All this hassle will be saved, and you unknowingly this data is generated, right? And that's how even you start getting implementation. If tomorrow some pharmaceutical company, okay, some pharmaceutical company has tied up with this application, maybe they will start telling you or giving you advertise nowadays. Okay, we have come with multivitamin, Pfizer company, Dr. Reddy's lab, let's say Cipla company, okay, Dr. Reddy's lab, Cipla company. They'll say, oh guys, now we have realized that you are passing through this disease, and maybe you can do this with, we are having a very good discount. We are giving you 10% discount on multivitamin. We are giving you 20% discount on vitamin D tablet. See how the things are working. Even the companies are getting smarter. They will try to catch your data, okay? And they're already diagnosed that you are having this deficiency sleep disorder. And even they realize that this kind of medication is available. If they try to connect to your application, or maybe it is given to third party application, and on the basis of that, pharmaceutical company can directly start selling to you guys, and even they can run a campaign. Okay, this kind of discount we are having, and it will be delivered, guys, to your doorstep. Don't worry, you don't have to go anywhere. It will be delivered. All this medicine will be delivered to you guys. Okay. What do you think, guys? Isn't it amazing, right? Knowingly or unknowingly, guys, just quickly put on your thoughts that how the AIs or machine learning is affecting your life. Even you would not have imagined that what kind of scenarios will be covered here, and how the even pharmaceutical companies, even the delivery people, right? Even the doctors, even the healthcare application specialists, and the smartwatches, obviously, the electronics. Everyone is trying to get advantage. And have you guys even given any permission to use your data? Okay, have you guys given permission to use your data, whether it is ethical? It's also a question. Yes. Whenever you install any app without reading any condition or without reading anything, you are directly giving yes. Okay, I agree to your terms and condition. Whatever data you want, you can collect. So they will collect even your contact number. They will also try to look at the your social media profile, because all the social media platform in the background, why they are giving you free access is they are selling your data to this kind of companies, which in fact trying to analyze your behavior, customer, and they're trying to build. Correct. AI is tracking everything. It improves the decision making based on the different. Correct. Guys, just quickly give me, have you ever guys thought that it could be a real implication, or how deep this AI or machine learning going into your life, and how everyone is trying to get advantage, right? Just give me a couple of thoughts, guys, in the chat box, and so then we can move ahead, and I will make you a code walkthrough. Okay, guys, just quickly just tell me that what you think about this use case, and whether you guys were actually aware of this use case, that what is happening, how is happening, and how we are even fooled by the companies in name of the free softwares, and how the machine learning actually taking out the data out of your life. Okay. Just quickly says, guys, if you give a response, it will be very nice. At least I will be able to understand that I am able to give you a correct use case, and then you can understand how you can solve this use case, right? Just give me your thoughts that the use case is clear and this is exciting or not, or what are your thoughts? Quickly, few thoughts, and then we can go to the programs. Yes, I am aware. Okay. Pandit sir is saying yes. Patil sir is saying we really learned from it. It is clear. Okay, guys, couple of more people, at least. And if anyone having any other thought or something like that, exciting comments, that is most welcome. It will affect manpower in future industry, right? I don't think so, because still, even though there is a technological advancement, and as long as we guys are adopting the AI in our daily life, maybe the survival of the fittest will be a question. But still, I think human will surpass to everyone in the coming future, because even in the history, people have proved that they can survive any odd condition. It might be helpful for improving the lifestyle from the model prediction. Correct, guys? There are always pros and cons. Okay, there is always pros and cons. We can consider it, but unknowingly, the question is unknowingly how you guys are sharing information, and how your guys are falling for the free apps, and how they are trying to exploit. Because if tomorrow they make a contract with you that whatever information we're taking, we have to pay you. Imagine what kind of situation will occur, right? In case of Apple company, should be collected a data from what apps or another mobile app indirectly. I don't know how the Apple is doing, but guys, most probably they might be doing the same thing. Even you have seen, guys, the case where Facebook was sued for the unethically tracking the person's data, and it was a huge or very buzz in the market, right? They exploit even with the search history of our web browser, correct search. They are not leaving any single opportunity where they can explore, or they can exploit you guys. Okay. So a couple of more thoughts, guys. If anything interesting you would like to add to this situation, or have you guys ever felt this kind of things which you guys have show some code for the teaching lesson. Okay. Yeah, code I am going to teach. That's why I'm telling you guys. But at least, if what is your thought? Have you also came across this kind of situation, or what do you think about? There's a couple of intuition I'm trying to take. Then maybe you can move to the code. Code is a not big thing, guys. Anyone can write a code. Even Chat GPT is writing code for you guys. What you need to understand is how it is happening in the background, what could be the use case, how we can solve it. Once the entire flow is once you are aware of entire flow and what is the system architecture you are trying to implement. Yeah, we can implement. This is what we're going to do today. We're going to implement this in Python. Okay, guys, I think enough of discussion. Let's go to the code directly. So people are very rigorously waiting for the code. So first thing what we'll do is, this is a Jupyter notebook screenshot, guys. So I'm not purposefully taking a Jupyter notebook. I am just taking a PDF here. So it will be easier for you because there will be no changes done and we can easily go over it. So this is not an entirely coding class. So you guys can at least understand how by coding or by how by visualization we're trying to solve this problem. So first what we'll do is, in first step, And wherever we start any algorithm, we try to import the different libraries which are required. Okay. In this case, we spoke about different frameworks or libraries which are available in the Python, right? So the NumPy, again, why it is good, why it is there to perform the calculation, right? So also pandas, also we have pandas as PD. Okay, matplotlib, again visualization. Okay, we create the graph. Cbon, again visualization, and then plotty and also graph. Name itself is clear, right? Plotty as a go. So we are taking for the visualization, and these two libraries we are taking for the mathematical calculation, right? So there is one more library which we should have imported. I think later on they will import, which is scikit-learn. Okay? We saw scikit-learn, sklearn. Someone say sklearn, scikit-learn. This scikit-learn library is giving us the entire packages where we can directly go for the algorithms. Algorithms are already available in these packages. Whatever regression, classification algorithm, clustering algorithm, every implementation is available. We just have to call the function from this sklearn, and that's it. So this is the minimum requirement, guys. In Python, what we'll do is we try to first import all the different libraries, and just we trying to just ignore the warnings. Okay, that's what we'll do. Then once we ignore the warning, okay, then what we'll do is we try to import the data using pandas. Okay, pandas.read.csv. I'm trying to import the CSV file into the data frame. Okay, here. That's what we'll do first. So once I import the library, and I will confirm with the warnings. So what we can do is we can import the data. Once we import the data, guys, this is how my data will look like. There will be certainly certain columns which are available for my disposal. So let's have a quick look. So first column will be gender, age, then occupation. What is my occupation? Whether I'm a software engineer. I will go into detail, guys. This is just a simple screenshot. When we go ahead and we'll try to have a look at the entire columns which are present. Okay. So like I said, I have to decide whether I am having a disorder, no disorder, okay, or whether I am in between this disorder, apnea. It is called as apnea. Okay, these three category. This is my aim, and for that purpose, I am looking at the gender, age, occupation, sleep duration, okay, within hours, quality of sleep on scale of 1 to 10. Okay, and then physical activity level on scale of 1 to 100. And stress level. What is my stress level? Then my BMI category, guys. Whether I am an overweight person, whether I am normal person, or whether I am an obese person. Okay. This is a few of the columns, and this is how the data will look like. Let's move ahead and try to understand. This is just the df.head, guys. When I do df.head, data frame.head, I'll be able to see my couple of records along with the different columns which are available, or features. You can call it a feature which are available. And what next thing I will do is I'm taking a tail. Like I'm trying to look at the top 5 and the bottom 5 example of my data, right? That's why I'm using df.head and df.tail. So it's giving me a top 5 records from the above and from the below. That's in the bottom. Okay, same thing I am trying to look at. Then what I'm trying to look at is how many rows of data is present. So we can do a df.shape, data frame.shape. Then I saw that there are 13 columns, okay, and there are 374 rows. DF represent what? DF means, guys, data frame. Okay, if you look at this code, DF equal to, we are reading this entire CSV file, right? And we are calling it as a DF, data frame. So whatever sleep disorder CSV file was there, we're trying to read it, okay, just for the confirmation again, guys. And we are calling it as a DF. Once we say df.head, that whatever data I have imported as a DF data frame, okay, I'm trying to look at the top five records and bottom 5 records. So I can get at least some feeling that what could be how the data looks like, but we still not through with the data. So what we'll do is we try to analyze that how many columns are available, that is shape. We'll try to look at the shape of the data. Okay, by looking at the shape, I understood that there are 374 records and 13 columns are available. So like I told you, we'll try to look at the columns separately. So df.column will give you a number of columns with the name of the column. So we saw person ID, we saw gender, we saw age, we saw occupation, sleep duration, stress level, activity level, in scale of 1 to 100, right? Stress level, also one scale of 1 to 10. Quality of sleep, like what was the quality of sleep between scale of 1 to 10. We also saw how much hours of sleep you guys are getting, right? So what next? We saw also BMI category, whether you are obese, no obese, right? If they're overweight, obese or something like that, right? Normal. Then people also looked at the blood pressure and heart rate. Like I told you, these things will be also coming from the smartwatch itself, and daily steps you are taking. How many steps you are taking on daily basis. Okay, that could be also generated using the smartwatch. And then finally, this sleep disorder. Okay, the sleep disorder, three categories we spoke about, right? The next thing I told you guys, if you could remember the life cycle, that whenever we trying to first import the data, we try to have a look first, overall look, that how many records are present, what are the columns available. Once we see that, maybe we'll start with the data cleansing, right? Or told you that 60% of the time when we import the data, we're doing data cleansing and data visualization, right? And trying to select the features. So for that purpose only, what we're doing is we're trying to find out if there are any duplicate values available in our data frame. That is the CSV file which we imported for the patient's data, right? So there was zero values. So okay, I can confirm that there are no values. So df.duplicate is a function, and then I am trying to sum all the duplicate values. Okay, once I am aware that there are no duplicate values, then next thing what I can do is I can go column by column and try to find out, are there any null values? Okay, are there any null values in the column? All the 15 columns or 16 columns which we were able to see. Okay, so whatever columns we are able to see. Okay, all the 13 columns, right? We have the 13 columns over here. So I am trying to see if there are any LA values, because guys, if there are any values available, whatever statistical measure we're trying to apply, maybe you will get an error or will not get a correct, accurate figure out of the statistical measure. That's why we have to check the sanitization has to be done. I check the duplicate values. I check if there are any null values available as per entire all the columns. Okay. So there were no null values available, zero. So it is good to go. So we can look at the next thing then. Once I know that there are no duplicate values, no NA values, what I can do is now I can go for the info. Okay. So why I'm looking at the info is I am trying to understand, okay, that within my these columns, what are the columns which are categorical columns, which are the columns which are numerical. Okay. In this case, I'm just trying to analyze whether this gender column, if it is a category column, text is available, it will give me as a object. Okay. If it is a numerical value, either it will give me integer or a float. You guys are might be already aware what is integer, float. It is a different type of numerical variables which are available accordingly, right? If your data is within points, right? If data is between 1 point something like that, so floating number. So that is called as float. Now, if it's a whole number 1, 10, 100 something, that will be integer, guys. Simply understand, try understand. And if it is if it is a category like let's say gender or let's say occupation or something like that, is a text value, character value, right? So everyone is, I'm sure everyone is aware of that. So what I did is I tried to look at the info, and by looking at info, I got the value count again, and how many nulls are available and what kind of data type is available in those, right? So depending on that, I can take a decision. Okay, this is a character data, means all the characters should be present within that, right? Though there should not be any numerical value present. So once I am aware of these things, then I can go ahead and describe. Okay, once I describe, I can look at the different statistics, guys. Looking at the data. Okay, what are the overall count? What is my mean value? Okay, let's take age. Okay, there are 375 records for the age. So what is my average age, guys? 42 is my average age. So whatever patients I'm looking at, the 42 is the average average age for my patients. Okay, so what is the standard deviation? What do you mean standard deviation from the mean? Let's say, okay, draw it here. So when I try to plot my data, okay, in the distribution. PDF material for today's. Yeah, guys, we will be sharing this material. Don't worry. Okay, every material will be shared. Don't worry. But we are still not complete. That's why we have not shared it, right? So what we're trying to understand is what is standard deviation. Okay. So when I try to plot my data, obviously there will be center of my data that will be called as mean. Okay. And from that data, center of data, how my data set is spread, like how far it is spread. That will be calculated by the standard deviation. Like how much is the deviation where data is spread, right? Like that. This is my data. Then how my data is spread, whether it is spread far away or whether it is collected near the center. How much percentage of data lying here within center, how much line in here. In normal distribution, how it happens, 65% of my data lies in here. Then remaining 30%, or let's say we take a cumulative one, 78% of data within this range, and then remaining all 99% will be covered within 1 to standard deviation. Only. So this major part is covered the 65% of the data, or 68%. Then coming to this part, let's call it under color. To this part, okay. So it will cover my 78 to 80% of the data, and then remaining this one, till this one, all my 100% data will be covered, right? This is called as normal distribution. Most of us are aware. So this is 1 standard deviation. Okay, this is 2 standard deviation. This is 3 standard deviation away from the mean. That's how, guys. So that's what we're trying to measure. That what is standard deviation, what is mean, how much data lie within 25%, 50% of the data, 75% of the proportion, and what is the max value. This kind of statistical measures is already available there. Just have to type df.describe, and we will be able to understand that what kind of pattern is available in the data. And on the basis of that, we can also see whether my data is normally distributed or not. If it's not normally distributed, maybe there is data available here somewhere here. So that means it is an outlier. So I need to remove that data. That could be one of the reasons that why we are trying to perform this exercise. Okay. So once I'm aware, like I told you guys, that there will be a lot of application time which will be spent into the data analysis. So this is the example. That's what I'm trying to do. So then we are trying to understand out of this entire data set, we try to look at the average mean, what is the largest value, what is the less value, minimum value. Then we try to understand how many unique values available in entire column, right? So let's take a gender. Gender is, we have only 2 categories, male or female, right? So that's what we. And age, there are 31 different unique values are available, right? There we have 11 occupation. Guys, don't worry about this data, because when I going into the visualization, it will be more clear. Just for the sake of understanding, we're trying to understand that how many unique values are present in each and every column. That's what we're trying to look at, right? Sleep duration, 27 values, and accordingly, right? Blood pressure, sleep disorder, and everything. And data type is 64, because we're giving a number for everything. Even though there are categorical values, but we're trying to measure these values, how many unique values are present. Once I am able to see what are the new unique values are present, okay, guys. So check, we need to check the data object, okay, accordingly. So once I know that these are my numerical columns and these are my categorical columns, so I'm trying to understand, looking at the each data, the person ID. Okay, I'm trying to bifurcate that numerical columns, different numerical columns and category columns, trying to bifurcate them and try to look at the data. So person ID is numerical columns, so it will give me what all numerical columns are available and what is the data available. So person ID is a numerical column, so it is showing me the data. Then age, then sleep duration, okay, quality of the sleep, stress level, all this is numerical. So it's bifurcated the numerical data separately here. Okay. Here bifurcated separately numerical data and the categorical data, that is text data separately. So this way also I can have a view at my data, right? So that's what the code says. Just try to print column, take a column and check whether this is a numerical column or no. If it's a numerical column, then try to bifurcate, try to print it, right? This way it has created this one, right? Then what I'm going to do is, now I saw an overall picture, guys. I did not take a single column. So what I saw is, I taking all these 13 columns and trying to understand that what is the data available, what kind of data is available, whether data is complete or not complete, whether there are any values, whether there is duplicate values, what type of data is available within those columns, right? What is the highest value, what is the lowest value, what is the mid value, how many counts are there any missing values, right? And combinedly, I'm trying to look at the data using the statistical viewpoint. Now, once I saw combinedly, I'm satisfied, then I will try to pick up one column each. Let's say I will take first one gender column, and then I will try to see bifurcation between gender column, and I will try to put a graph around it. So by looking at a graph, you can easily visualize if there anything odd, or whether this data is balanced. What do you mean by balanced, guys? So whatever number of males are present, are that proportion, same proportion is available within a female or no? where the data is proportionate between these two categories, male or female. Because tomorrow it should not happen when we are trying to fit a model, right? So if it is an imbalanced data set, let's say 90% of my data is about the males and only 10% of the data is for the females, obviously it will be more prone to the male category of data and we'll try to give it the same data, right? Now guys, attendance is shared by Amar. You can mark the attendance, guys. Okay. As and when you are getting done, you can mark the attendance simultaneously also. So what we're trying to understand is we're taking each and every column, whether this column are categorical column, and try to see what is there any balance between the data which is available within the columns, right? So I can see a proportion of data in this case in our available data set. Okay, proportion is not that disproportionate. They are almost equal to each other. That means we have a balanced class data, right? Whatever percent of male are available, even close to that, females are also available. So this is a good sign that our model will not be biased. Okay. Then second graph, again, we'll try to use, once we saw the frequency distribution, we trying to look at the distribution in the terms of the pie chart also. And this will even give you a more sense, because here it was not able to give you a more exact sense, right? At least I was able to see that it is close to each other. Here I am getting exact equation that 49% are female and 50% are male. So this concludes my hypothesis. Okay, there is not a much disproportion among the data. Okay, then I will create another graph, gender, okay, bar graph, and I try to put count. Here the count was available, but I just did not take into consideration the entire scale, right? And looking at the data now, I'm taking a scale which is somewhat less and trying to understand what is the gender data available and how it is going as per the scale. Same thing, guys. Okay. Once I am taking this data, then the next column, okay, then I understood that, okay, first gender column, there are no issues. The balanced data set, it is a balanced data set and all the proportion are in the good proportion. So we can good to go ahead with it. Then we can take a next column, occupation. Now these are the unique occupation and number of value counts. If I take a value count, give.value, it will give me for the different occupation, what is the count, right? And simply I will try to put it in the bar graph. Then I can understand, okay, which are the majorly heavy occupations which are covered here. So you can see that scientists and the software engineers are less here. Okay. So when I am assuming, when I'm trying to create any assumption on the model basis of the model, so what I can say is I have taken a balance of everything. That means I have taken into consideration when I am trying to conclude anything. I am taken into consideration all the profession. Because tomorrow, if you do any research on the basis of this data, people can easily say, okay, whenever you did a research, it was biased because you had more doctors, maybe, and you had more nurses, engineering occupations, but there were less scientists and there were less software engineers. So, and there were less managers. Okay, this data was less, so it does not give a generalized. It does not give a generalized prediction. It is not giving a generalized prediction. It is biased towards certain profession because that kind of data is more. So what I can do is I can go back and check the data and I can take a balanced data set if I want to make a generalized prediction, or what I can do is whatever entries are available, I can do a upscaling. So in same proportion, there are certain functions are available which are used for upscaling. And I can, based on this, I can do upscaling or increase the count. Simply understand, I can increase the count of this data set. And then I can say, okay, with 100% confidence level, so that my data or model will be able to generalize this prediction across all the occupations. That's the same, just the only exercise we are trying to understand. When you are trying to say that, okay, guys, when you are trying to say that what kind of occupation I have scored, because I am trying to make a very let's say intense prediction that whether this person is suffering for my model which is created is going to predict whether this person is suffering from sleep disorder or not, and my model is working correctly at that time. Looking at the data also, it should be able to prove that hypothesis, right? So that I have taken each and every category of person into consideration when I am studying this kind of hypothesis. That's why we are trying to look at this data. Okay, yeah. So again, the same thing, we are looking into percentage because we are just trying to look at the data, but we are not exactly able to get the figures. by pie chart, you can say what proportion of data lying with the what proportion, and accordingly you can take decision. That's why we are trying to plot a pie chart. Pie chart. PLT.pie chart is the example. We don't have to go into details like what are there. Just try to understand that this is a function which is available in the matplotlib. Okay, PLT, we are taken matplotlib or Seaborn, whatever is there. We are taking this into consideration and then try to make the visualization, right? Similarly, we sorted the data of the occupation and we tried to see which one is going for the higher one, and then accordingly we managing the data, arranging the data in the descending order, so we can take the decisions. So this how it came on. The more in previous way we did not sort the data, right? It was not giving us a correct impression about the data. So here what we do is we sorted the data and we then try to plot the data, and then we try to look at the data. Then it give us the impression that this kind of occupation not covered as. Then you can take a decision whether you want to make an up sample or down sample accordingly. So it is a balanced data set again, right? Balanced set of data for all the occupations. Okay, guys. So let's we saw occupation, we saw gender. Okay. When we saw next column BMI category, because in BMI category we have three categories. One is normal, overweight, and obese. So these are the unique values which are available. We had in general how many values are available. According to that, we are trying to look at the data. The same thing, bar plot by charts. We'll try to plot by charts, and we try to understand what category of data is available. We can see that 50% of our patients are having normal BMI category, then followed by the over people, which are coming to 40%, and then obese only comes to 2%, and normal weight is one more category which they are trying to add here, is coming to 5%. So out of my patient, I can say my 52% are having a BMI category of 50% having a normal BMI category, overweight, and so on. So again, it's the same thing that why we are going to do visualization is same purpose to look at the balance in the data. Same chart I'm trying to draw again and again for with the different columns, right? That's what I'm trying to do. Now coming to next column, sleep disorder. In sleep disorder, we're trying to see sleep rate. What are the categories available, right? Sleep disorder. This is a target column, guys, which we are trying to look at. We try to solve what are the unique values, and accordingly we try to plot it. We take the sleep disorder. Okay, guys. In blood pressure, there is also two types. Okay. Whenever we are trying to measure blood pressure, there will be higher blood pressure, lower blood pressure, right? Systolic and diastolic. Systolic means when your heart pumps out the blood out of your heart and it reaches to vein and other body part. And diastolic means what? Whenever whenever between the heartbeats, your heart stops for certain seconds. Okay, at that time there will be certain blood pressure available. Okay, that kind of things is available. They have taken also consideration into these things for the blood pressure, and they are trying to split this data according to the blood pressure, right? So in that they are taking a different data set again for the systolic and diastolic, and then accordingly they're trying to how to choose a chart of type of chart for this information particular, guys. It depends. We try to look at a different data set and different business situation. On the basis of that, we are trying to look at how the information is passed to us and how we are able to make it. This is no one choice, guys. We try to do a visualization with a different data set. Let's say whenever I am trying to look at the data and I'm just interested in the proportion, then I can go for pie chart. If I want to actually measure the data's distribution, so I can go for the histogram, and on the basis of the histogram, this is the histogram, guys, which we are seeing. Our histogram will be giving me along with the counts, the distribution of the data. Okay? This will be giving me between the range and the here and there how many values are lying, and on the basis of that, if I try to join the midpoint of this data graphs, bar graphs, it will try to give me a curve which will be telling me that how my distribution is looking like, whether it is a normal distribution or whether it is not a normal, whether it is going above that or below that. On the basis of this certain statistical measure, again I can look for the data. So it's also important that we try to look at for different purposes, right? There are different data sets available. Whenever we're trying to look at the distribution of the data, we'll go for the density curve and we'll go for the histogram. Whenever I want to look for the whenever I am looking for the proportion of the data, I will look at the pie chart. So I can understand the proportion. Whenever I am looking at only for a count, interested in the count, so I can go for the bar graph. Okay. And also there is there will be more graphs which are coming into picture. I will tell you the importance of this graph and for what purpose these graphs are used, right? Where we get this data for practice later. Don't worry, guys. Everything will be shared with you. My voice is breaking, guys. Few of us are saying that my voice is breaking. Just confirm if my voice is clear or everyone is able to hear this. Just quickly, just tell me clear, clear, clear. Okay, guys, let's move ahead. So what we were discussing that what kind of chart is used for what purpose? Like telling you that when we go further in this discussion, guys, you will be able to see that there will be more chart use and what is the purpose of that, right? Just quickly go through it. So we saw we took a next column, okay, for the blood pressure, and in that systolic and the diastolic. Let's say I'm not sure. Systolic, okay, systolic, and what is the next category? Diastolic. Systolic, I told you, whenever a blood pumps the blood out of the heart, whenever heart pumps out the blood out of the heart towards the veins, that is called as systolic. Okay, when the entire blood flow is from heart to entire body parts. Okay, this is if they start from heart to other body parts, it is called as systolic. And for diastolic, this is between the rest time of the heart between the two heartbeats. So that's how the implication is there. Okay, and they're trying to look at this data also, guys, and what kind of data set is available, whether it is normal blood pressure is falling within a normal range or not. That's the only purpose they are trying to do it. Okay. So that, guys, I told you that there will be one more interesting visualization. It is called as box plot. So let's try and understand the box plot. Okay, I told you what is this box plot. Try to understand very quickly. And this is very super important concept, guys, this box plot. What happens is when I saw this systolic, I took this data and I tried to put this visualization. What this graph means, let's try and understand. This one is upper hinge, guys. This is upper limit. You can say upper limit. And this is the lower limit of the data. Lower limit. Okay. This is upper limit. This is the lower limit of your data. And these are the quarters, guys. Okay, in between. Let's say this one is quarter 1. This one is your mean, quarter 2. This is the quarter 3. And this entire data set, I will try to fill in with this. If I am taking my entire 100% of the data, what I am doing is I am trying to bifurcate them within the quarters. This is my first quarter, this is my second quarter, this is my third quarter of the data. Okay. So I'm just trying to distribute this data with this green part is 25% of the data in quarter 1. Okay, we saw. And here it will be 50%, up to 50%. Then here quarter 3, 75%. And then here it will be 100% of the data. So we are trying to visually bifurcate the data and try to understand, okay, how the data looks like. So this is quarter 1, this is quarter 2, quarter 3, and this is the upper limit. Okay, upper limit, and this is the lower limit. Why we need this data, guys? Lower limit and upper limit. If any data point which is lying beyond this upper limit or lower limit, obviously, like let's say like this one, this data is available here in your data set, which is lying below that, it is called as outlier, guys. It is outlier data and we should be removed from your decision making. Otherwise, yes, correct, guys, it is outlier. So that's why this box plot is playing very important role. We try to find out any odd values, okay, any odd values which are available, okay, just like this, which are not falling into your data set correctly, and which are the far, we can also call them as a noise. Okay, these are the noise. If you try to build a model on the basis of the noise, obviously the prediction will go haywire and your model will not be robust. That's why we need to remove this data. That's why we are using this box plot. It is one of the techniques how to decide the outliers. Or how you can decide, you can also decide the outlier on the basis of the standard Z scores also. Or so there are also certain other measures, but now this is not the time to talk about it. Just try to understand quickly what we are doing, because you guys seen now till the time we are still doing a data visualization and data part. So you can understand when I made a statement that 60% of the time you guys will be performing the data visualization and everything. So that's what it means, guys. You are taking each and individual every column, try to understand the data points available, how data is behaving, This is again violin part, guys. This is just the fancy item. This is nothing but the box plot. The same purpose it will serve, but if the shape is somewhat fancy, it is called as violin plot. Similarly, we took the another diastic and we try to perform the same operation on it. We try to check if there are any outliers. Okay. Then person ID. Okay, I will quickly go through the boxes, guys. Now we are all aware. Now we try to look at the histogram for the age, box plot for the age, and violin plot. Similarly, and we can what we can do is we can plot the graph against each other. Like I am taking a graph of the gender, we can also plot it against the age or something like that. Further bifurcation is also possible. Let's say I'm taking multiple graphs together in this case. Person ID with blood pressure, right? Guys, this is already shared. Attendance link is already shared in the mailbox, chat box by the Amar, so you can refer to it. Okay. So let's have a quick look. So what I'm trying to do here is, along with the person ID, I'm trying to match two columns together. So you can say is a bivariate graphs simply because we are taking two graphs, two dimensions together. We try to visualize them, right? So once we guys through with the visualization, right? What I told you. Okay, we are done with the visualization. We've seen what is available. If there anything wrong in it, then what we can do is now we can select the data. Okay, and whatever data categorical data is there. Obviously, whenever we trying to feed the data, in case of email and okay, there will be different techniques which will be used in the NLP guys. Whenever we trying to classify the emails and all. So again, this is a separate topic. The things like this kind of things will not work. They have a separate measures. Okay, guys. Amar, can you just put attendance sheet again because some of them are asking that they did not receive your attendance link. Just try to paste it again so everyone can follow it. So what happens is, guys, what we're discussing is that when we selected all the columns, we selected everything. Okay. So we draw the graph, we try to saw any values, we clean the data, everything. Whenever there are categorical values, we just cannot feed these categorical values directly to the machine learning algorithm, right? So what we have to do is we have to put them into the numbers. That's what they are doing, encoding. Okay. Let's say, what do you mean by encoding is, let's say gender, we have a male, right, and female. So machine learning algorithm will not understand male, female. It will understand like this. If it is a male 0, then it is a female, I can give 1, 0, 1. So this is binary category. In occupation, we have several categories, right? So for several categories, it will do a label encoding and will try to come up with a number. Or what I can do is, we can create a separate column within the data set, a different occupation, and accordingly it will give 0, 1, 0, 1, 0, 1. Let's say if it is an engineer, 0, yes or no, whether he is a doctor, yes or no, or what he can do is, he can assign each particular occupation one number. Engineer will be given one number, 1, doctor will be given number 2. But if we try to do giving this number in this case, then it might understand that engineer has a more weightage or doctor has more weightage because the number is more. So that kind of confusion also can be created. That's what we do is usually we try to create 0, 1, or we try to add the columns. So whatever 13 columns are there, in addition to that, we'll create extra column and we'll say whether profession, for every profession, there will be one column, engineer, doctor, nurse, okay, engineering student, or other people, and there will be 0, 1, 0, 1 coding will be given according to the data set. Yes, quickly try to understand. There's no hardcode logic. Just we cannot give numbers because if you try to give numbers, it may understand that it has a higher weightage. That's why we have to keep a weightage same. So once we do it right, that I told you that once we are done with the visualization, we have to understand the correlationship. Okay, this is the graph of the correlationship. Try to understand this. So in this correlation plot, this is called as heat map, and within that heat map, okay, I'm plotting a correlation matrix and I'm taking entire data set against each other. That's what I'm doing. And within that, you can say that it is plotted against the age. I can say against it. Let's make it bigger. You guys can understand. I can read it in this way. So this is age and what is the sleep disorder? Okay, this is a sleep disorder and this is age. Not this way. Yes. You see this second column is sleep disorder. So sleep disorder age. So what I can do is this will be the number for age and below column is for sleep disorder. So this will give me a correlation between these two columns. Accordingly, this matrix is plotted against, right? Let's understand. And whenever there is high correlation, okay, whenever there is a high correlation, so it will be done by the color coding. The more brighter the towards the redness, the more correlation, and if there is a less correlation, it will go towards the blue side. That's how. So it can understand, right? Try understand guys this number. Okay, this is 53%. This is the correlation between age. Okay, the correlation between age and BMI category, right? So age and BMI category has a 53% correlation. That means they are highly correlated to each other. Okay, that's how. That's how we try to find out the correlation. Why do we try to find out correlation? Because if I'm taking all the columns, it may not be necessary. If the columns are correlated, I can drop one of them, or I can choose one of them also, and accordingly I can build my model, right? So let's quickly go through next thing. Once I know how to what to select, okay, this is the same label inputting guys that I have done for sleep disorder, quality of sleep. These were category problem. I've given a numbering for them, right? So guys, this is very super important topic, guys. Within 10 minutes, we will be able to finish. Now we are coming to what we have done till now. I understand from this point of view, guys. So are you guys able to see the life cycle? Okay, life cycle presentation. Just quickly tell me yes or no, guys. So I can explain you that what all things we have done according to coding and according to the graphs. Okay. Okay. Share again. Okay. Now I think you guys are able to see, right? Just quickly give me confirmation. Yeah. Okay. So what till now you are seeing in the code what we have done, right? We took the data set for the sleep disorder patients collected. We did entire cleaning, right? This part we done. First part was this one. Then second part we did this one. Data cleansing, like we saw NA value, duplicate values. What is the value count? Then what we did is feature engineering, or say feature engineering in the case of visualization, exploratory data analysis. Third step, we try to plot different graphs. Then we try to solve the correlation matrix, right? And on the basis of the correlation matrix, we'll try to decide that which are the final columns, okay, which will go into the model. So we have reached to this stage, guys. Now this fourth stage, because we are done with the visualization and everything. Now this is fourth stage we are trying to follow now. Okay, let me quickly go back to the code then. So you guys are able to see how to get test set. Okay, I will discuss this later on, guys. So now, guys, we were able to see data cleansing. We are able to decide how to clean the data. We will see how the graphs works, right? And then once the graphs works, now it's a time that we call our model. Okay. So for calling the model, ExcelR is the library I told you guys. From ExcelR, we are trying to import a random classifier, random forest classifier. Okay. Once we call this random forest classifier, okay, what I am trying to do is now here I am trying to get the sleep disorder, drop the target variable from the feature. What I am trying to do is I am trying to split the data X and Y. I'll tell you what I am doing. Okay. So these were my columns, right? All the columns, and there was a sleep disorder column, right? So this will be considered as my target, right? So that this target will be called as Y, and all the other columns will be called as X. That's what I'm trying to do. I'm trying to split X and Y, and differently I'm telling you this is the X, these are the feature, and this is the prediction which you have to do. This is the Y, and this is the X. That's what I'm trying to simply do here, guys. Okay. So once we do it, right, what will be the next stage then? So we have decided what is X and what is Y, what is target, what is feature. Then CLF. CLF equal to, I'm just trying to assign this model to a variable CLF random forest. Okay. Once I assign this model is completed, guys, right? Model is completed, then we have to fit. Once I say fit, the training will start, guys. This is the stage. For this stage, once I say CLF, because CLF is equal to random forest, and then I will say fit. Once I say fit, okay, and X and Y, it will start the training, guys. We start the training. Okay. Once you start the training, and then model will be done. So we can do a prediction that's directly. So here what we are trying to do is we are using the random forest. We took the divided data target and column. We assigned it to random forest and we provided the data X and Y. Now on the basis of that, we'll do a prediction also. But before that, what they're trying to do is they're trying to understand that what is the importance of each and every feature. Like I told you that we need not to take entire all the feature. So this is also possible that I try to fit a model and then try to look at the parameter called as feature importance. So these are my columns, and in front of that, I am trying to print a feature importance. So if you see BMI category has the highest importance, followed by the systolic blood pressure, or diastolic blood pressure, and then the BMI category, other category, right? So maybe on the basis of this, I can also decide, okay, this has a very negligence importance in the decision making. So maybe we can decide out of all these 25 columns, because why 25 from 13? Because whatever categorical columns were there, right? BMI, there was only one column. So what we did is for BMI, we created 3 new columns: BMI category overweight, BMI category normal, and the BMI category obese. Okay, somewhere here. BMI category normal weight, BMI category obese. So 3 different column out of 1 column we created, because we cannot just feed the data accordingly just for the columns, right? And on the basis of that, we try to understand what is the important columns available, and we can take just those important columns, and then we can again try to learn the model. Okay, again, what I'm doing is now I am trying to import the model logistic regression trend test split. Guys, someone was asking that how can we split the data? No, guys, random forest is not only used for the feature importance, it can also be used for the prediction. But what I'm trying to do is first is still a part as a precaution. I'm trying to fit a model and try to, because random forest is such a algorithm which gives me also feature importance. But what are the important features which are helping me make a decision? That's why first I try to fit a random forest and try to look at the importance. Once I know the importance, I can directly take the important columns and again try to fit a different model on that. That's the only purpose. We can also do the same thing, guys. Okay, and so there's a function called trend test split, guys. You directly call trend test split and pass a data to it. Let's say in this case, we are trying to pass a trend test split data X and Y. What is X? All my feature. Y is my target column, whether there is a sleep disorder or not. And I'm trying to choose a proportion. Here, I'm choosing a proportion of 80-20, guys. Okay, 0.2 means 20% data will go into test and 80% data will go into train. That's what I'm trying to do. Then I'm calling a logistic regression function, guys. Again, I'm trying to fit. Fit means I'm trying to train the data. Once data is fitted, then Y equal to do prediction on the test data, and then we can choose the accuracy. Once we do a prediction, we can pass it to accuracy of function and check the accuracy, guys. So whenever I fitted this logistic regression, my accuracy is coming to 72%. That means my model is performed good. So it will be 72% of the times it will predict accurately whether there is a sleep disorder or not. So similarly, I can put a different model, decision tree, same thing, called decision tree, pass it to your training data, then try to predict and check the accuracy. So decision tree even giving more higher accuracy. Here, with the help of the logistic regression, we are getting only 72% accuracy. But here, what we are getting is 93%. That means this model is performed better. Okay, guys, that's how. Okay, we try to understand. So we will go with the highest accuracy model, that is this one. Okay, highest accuracy is 93%. So I'm okay with it. So I can go with the 93%. Whenever I pass, whenever I build this model, fit and then trying to predict here. So whenever you pass on the data here, okay. So X test, what is X test? I am passing all the columns. What is the age? What is the age? What is the gender? Okay. What is the blood pressure? What is the BMI category? All these values will be passed individually to this model then. Okay. DT is the model, and it will be able to give me a number, give me a prediction value, whether it is a sleep disorder, no sleep disorder, or there is a apnea. There's between it. So that's how it will work, guys. Clear, guys? So how we fitted a model, different model, and how the code will look like. This is it, guys, and this is what you have to do. Once you created this, then you check with all the accuracy. We are satisfied with the accuracy. Then you pass this model to the integration team. They will try to integrate in a web browser or maybe a cloud, or this web browser or cloud services. and they will create a model, create application, and then people will be able to use it. That's how it will happen, guys. Guys, clear? Just quickly ping me whether this is clear and you guys were able to comfortably understand the entire project, right? And how is the project is important. This is a really good use case, guys. And how, sir, how to choose a trend test ratio is again depend, guys. Usually what we do is we do a 80-20 split. Okay, guys, 80-20 split. But if I think that I want to do more rigorous training, what I can do is I can do a 70 for training, 10 for validation, and remaining 20 for the test. This can also possible. It again depends, guys. It again depends on how you're trying to solve a business case and what is the approach you want to take. You can take any of the approach. It's okay. You can do experimentation and then you can probably check that how it's going to work. So, guys, I think we have passed everything. Just quickly mark your attendance, guys. And I hope we completed the entire code walkthrough. And you guys are very well aware that now how a model is built and how prediction is done. What are the different techniques through which we can do a data cleansing, data visualization, and how model is fitted and how the prediction is done. I hope, guys, you guys enjoyed this session. Just quickly put in some comments that you guys enjoyed it. It was very nice, and whether you guys are able to understand or not. So we can tomorrow again start with the one more good project, and then we start with the deep learning. Try to understand what is deep learning, how the neural network works, what kind of neural networks are there, what are the limitations. We still left with the part where, guys, we are not able to understand what are the limitation of why a model, particular machine learning model should fall. So that we'll try to quickly cover today. So I think, guys, we already passed our time. So thank you very much. And just don't forget to put in some comments, whatever is there. I will share, guys. Don't worry. Every material will be shared with you guys since we are not completed it. So that's why we kept it on hold. Once we complete the session, then maybe we'll share with you so you guys can practice or use it for the different use case. Okay, so principal sir already told us that give us the assignment. So we'll give you this model and this code, guys, and you have to come up with a different model along with the different use case. That's what we can do. Thank you very much, guys, and don't forget to mark your attendance. And then see you tomorrow, guys. Then thank you very much. Definitely we'll share the material, guys. Thank you very much.
Thank you so much, all of you, for joining the session. We'll meet you on tomorrow at same time. Bye bye. Have a nice time.
Bye, guys. Have a good day.